Statement of the theorem. Let f be analytic in the disk BAR, then f of z equal to sigma n equal to 0 to infinity an z minus a all raised to n for mod z minus a less than r, where n equal to fn of a divided by n factorial, and this series has radius of convergence greater than or equal to capital R. That is, we have an analytic function f defined in a disk with the center A and a radius capital R. And also we have to show that this analytic function can be represented in the form of a power series sigma n equal to 0 to infinity an z minus a all raised to n for mod z minus a less than r, that is in the interior of the disk BAR. And we have to show that an is actually fn of a divided by n factorial, and also about the radius of convergence, that is the radius of convergence of this power series f of z is greater than or equal to r, that is at least r, at least capital R. ഈ തിയറം മറ്റൊരു രീതിയിൽ നമ്മൾ ഫസ്റ്റ് യൂണിറ്റിൽ പ്രൂവ് ചെയ്തിട്ടുള്ളതാണ്. ഡെറിവേറ്റീവ് സീരീസും അവിടെ നമ്മൾ എ എൻ ഈക്വൽ ടു 1/n ഫാക്ടോറിയലിൻ്റെ എഫ് എൻ ഓഫ് എ ഒക്കെ ഡിറൈവ് ചെയ്തിരുന്നു. സോ ഇവിടെ നമ്മളിത് പ്രൂവ് ചെയ്യുന്നത് ഇതിന് തൊട്ട് മുമ്പുള്ള കോഷീസ് തിയറത്തിൻ്റെ കോഷീസ് ഇൻ്റഗ്രൽ ഫോർമുലയുടെ സിമ്പിൾ വേർഷൻ ഉപയോഗിച്ചിട്ടാണ്. സോ വി ടേക്ക് capital R as the radius, so we take a number between capital R and 0, that is small r. That is ഒരു ഡിസ്കിൽ എ സെൻറ്ററും ക്യാപിറ്റൽ ആറും ആയിട്ടുള്ള റേഡിയസും ആയിട്ടുള്ള ഒരു ഡിസ്ക് നമ്മൾ കൺസിഡർ ചെയ്യുന്നു. അതിനുള്ളിൽ സ്മാൾ ആർ റേഡിയസ് ഉള്ള മറ്റൊരു ഡിസ്ക്, സ്മാൾ ആർ ലെസ് ദാൻ ക്യാപിറ്റൽ ആറാണ്. സോ ഈ ഡിസ്ക് BARന് ഉള്ളിലാണ് വരിക, ഇൻറ്റീരിയറിലായിട്ടാണ് വരിക. അതിൻ്റെ ക്ലോഷർ നമ്മൾ എടുക്കുന്നത്, അതായത് ബൗണ്ടറി അടക്കം ക്ലോസ്ഡ് ഡിസ്ക്കാണ് എടുക്കുന്നത്. ദാറ്റ് ഈസ് B closure of A small r is completely contained in BAR. Now we take gamma as the boundary of the disk B closure AR. B closure AR ൻ്റെ ക്ലോസ്ഡ് ഡിസ്കിൻ്റെ ബൗണ്ടറി എ സെൻറ്ററും സ്മാൾ ആർ റേഡിയസ് ആയിട്ടുള്ള സർക്കിളാണ് വരിക. ഗാമ ഈക്വൽ ടു മോഡ് z മൈനസ് എ ഈക്വൽ ടു സ്മാൾ ആർ. That is gamma of t can be written as gamma of t equal to അല്ലെങ്കിൽ z equal to, we can write it as a plus r e raised to it 0 less than or equal to t less than or equal to 2 pi. So by the previous theorem, Cauchy's integral formula, simple version, if there exists a function, analytic function f of z in some set in some closed disk BAR subset of a open set capital G, then we can write f of z in an integral form, that is f of z equal to 1/2 pi I integral over gamma f of w dw divided by w minus z, where w is a point on the circle gamma and z is a point interior to gamma. ഇതാണ് നമ്മൾ കോഷീസ് ഇൻ്റഗ്രൽ ഫോർമുലയുടെ സിമ്പിൾ വേർഷനായിട്ട് പറഞ്ഞത്. സോ ഈ കണ്ടീഷനെല്ലാം ഇവിടെ സാറ്റിസ്ഫൈ ചെയ്യും. എഫ് BA ക്യാപിറ്റൽ ആറിൽ കണ്ടിന്യൂസ് ആണ്, അതുകൊണ്ട് B ക്ലോഷർ A സ്മോൾ ആറിലും കണ്ടിന്യൂസ് ആയിരിക്കും. ആൻഡ് അനാലിറ്റിക് ആൾസോ അനാലിറ്റിക് ആയിരിക്കും. അതുപോലെ ഗാമ എന്ന് പറയുന്നത് ഒരു സർക്കിളായിട്ട് നമുക്ക് കിട്ടി. സോ വി ക്യാൻ അപ്ലൈ ഹിയർ ദി കോഷീസ് ഇൻ്റഗ്രൽ ഫോർമുല, that is f of z equal to 1/2 pi I integral over gamma f of w divided by w minus z dw. ഇതിലെ 1/w minus z എന്ന ടേം we can rearrange it as 1/w minus a plus a minus z, adding and subtracting the term a. So 1/w minus a into minus of z minus a. Now if w minus a taken outside, we get 1 by w minus a into 1 minus z minus a by w minus a. So 1 by w minus a into 1 minus z minus a divided by w minus a all raised to minus 1. Now this term z minus a divided by w minus a, consider the modulus of this term. We have a circle with the center A and a radius small r, and this is we called gamma. Center A radius small r ആയിട്ടുള്ള സർക്കിളിനെ ആ ഡിസ്കിൻ്റെ ബൗണ്ടറിയാണ് നമ്മൾ ഗാമ എന്ന് വിളിച്ചത്. ആൻഡ് w is a point on gamma. w സർക്കിളിലെ പോയിൻ്റാണ്, z is സർക്കിളിലെ ഇൻറ്റീരിയർ പോയിൻ്റാണ്. സോ മോഡ് z മൈനസ് എ എല്ലായ്പ്പോഴും മോഡ് w മൈനസ് എ അത് ആറാണ്, സ്മോൾ ആറാണ്, ചെറുതായിരിക്കും. Therefore mod z minus a by w minus a is always less than 1. So this is of the form 1 minus z all raised to minus 1, and also here mod z less than 1. Here also mod z minus a divided by w minus a less than 1. Therefore we can expand it as the form. We have the expansion of 1 minus z all raised to minus 1 as 1 plus z square etc. That is sigma n equal to 0 to infinity z raised to n. So here we can write 1 by w minus z equal to 1 by w minus a into sigma n equal to 0 to infinity z minus a all raised to n divided by z minus a by w minus a all raised to n. That's equal to sigma n equal to 0 to infinity z minus a whole raised to n divided by w minus a whole raised to n plus 1. This w minus a into w minus a whole raised to n means w minus a whole raised to n plus 1. So we can write f of z as the form f of z equal to 1 by 2 pi I integral over gamma f of w divided by w minus z ആയിരുന്നു. അതിന് പകരം we can write this summation into 1 by w minus z ന് പകരം sigma n equal to 0 to infinity z minus a all raised to n divided by w minus a all raised to n plus 1 dw. So we can rearrange this as sigma can be taken outside, sigma n equal to 0 to infinity 1 by 2 pi I integral over gamma f of w dw divided by w minus a all raised to n plus 1, and we can write this term z minus a all raised to n outside the integral because the integration is with respect to w, therefore z minus a all raised to n is a constant, and this term 1 by 2 pi I into integral gamma integral over gamma f of w dw divided by w minus a all raised to n plus 1, we call it as an. Therefore f of z equal to sigma n equal to 0 to infinity, this is an into z minus a all raised to n. That is f of z can be expressed as a power series where an equal to 1 by 2 pi I into integral over gamma f of w dw by w minus a all raised to n plus 1. Now we have to show that this series is convergent, and also we have to find the radius of convergence is greater than or equal to capital R. So for this we consider the terms f of w divided by w minus a all raised to n plus 1 into z minus a all raised to n, that is f of w divided by w minus a all raised to n plus 1 into z minus a all raised to n. Consider the modulus of this term. which is equal to modulus of f of w into modulus of z minus a whole raised to n divided by modulus of w minus a whole raised to n plus 1. Now we consider this on the circle gamma. So gamma is a circle with center A and radius r, and f of w or f of z is a function, analytic function defined in the closed disk. In the open disk, be a capital R. So f of z is analytic everywhere on the circle. A function f of z is analytic means it is defined at all the points. Therefore, f of z is defined on this circle. So we can find the value of f of z for every, or f of w for every w on gamma. ഗാമയിലുള്ള ഓരോ പോയിന്റിനും എഫ് ഓഫ് ഡബ്ല്യുവിൻ്റെ വാല്യൂ ഡിഫൈൻഡ് ആണ്, ബിക്കോസ് ഇറ്റ് ഈസ് അനാലിറ്റിക്. So we can find a maximum value for f of w. We take it as capital M, that is modulus of f of w less than or equal to capital M. So by substituting this, we get a modulus of z minus a whole raised to n divided by mod w minus a means r, because w is a point on the circle. So r raised to n plus 1. That is, we can write less than or equal to m by r into mod z minus a divided by r whole raised to n plus 1. Left side it is modulus of f of w into z minus a whole raised to n divided by w minus a whole raised to n plus 1. Now applying sigma on both sides, we get sigma n equal to 0 to infinity. Also here sigma n equal to 0 to infinity. Here m by r is a constant, so sigma n equal to 0 to infinity mod z minus a divided by r whole raised to n plus 1. And this series is a geometric series with a common ratio mod z minus a divided by r, and we have mod z minus a is less than r because it is a point. Mod z minus a is less than r because a is a point interior to the circle with the center a and radius r. Therefore this is less than 1. So this series sigma n equal to 0 to infinity mod z minus a divided by r whole raised to n plus 1 is a geometric series with a common ratio less than 1. Therefore it converges. So the right side is converges, and so therefore by Weierstrass M test for series, the series on the left side is also converges or uniformly converges. That is sigma n equal to 0 to infinity f of w into z minus a whole raised to n divided by mod w minus a whole raised to n plus 1 modulus illa that series sigma n equal to 0 to infinity f of w into z minus a whole raised to n divided by w minus a whole raised to n plus 1 is uniformly converges by the Weierstrass M test for series. So this series is convergent, therefore multiplying by 1 by 2 pi I, it is also converges. Also by integrating, or the term summation is replaced by integration, or taking integration over gamma, this is also again it is converges. So sigma 1 by 2 pi I integral over gamma f of w. Here we replace summation by the integration, integral over gamma f of w z minus a whole raised to n divided by w minus a whole raised to n plus 1. This term is converges. Therefore we can write f of z equal to sigma n equal to 0 to infinity 1 by 2 pi I integral over gamma f of w divided by w minus a whole raised to n plus 1 into z minus a raised to n. That's equal to sigma n equal to 0 to infinity a n z minus a whole raised to n is converges. So this power series exists and also it converges. And now we take 0 less than r less than capital R. Now we have given the result, that is radius of convergence is the radius of the largest circle at which the power series converges. We prove that the power series is converges on a disk with center A and radius R. So this R is arbitrary. This is true for any R less than capital R. So capital R വരെയുള്ള ഏത് റേഡിയസ് എടുത്താലും അവിടെയൊക്കെ ഈ പവർ സീരീസ് കൺവേർജൻസ് ആണെന്ന് കിട്ടും. ദാറ്റ് മീൻസ് ക്യാപിറ്റൽ ആറിന് താഴെയുള്ള എല്ലാ ഡിസ്കുകളിലും റേഡിയസ് ആയിട്ട് വരുന്ന എല്ലാ ഡിസ്കുകളിലും എഫ് ഓഫ് സെറ്റിൻ്റെ പവർ സീരീസ് അല്ലെങ്കിൽ എഫ് ഓഫ് സെറ്റ് കൺവേർജ് ചെയ്യുന്നു. അതിനർത്ഥം റേഡിയസ് ഓഫ് ലാർജ് സർക്കിൾ എന്ന് പറയുന്നത് മിനിമം ക്യാപിറ്റൽ ആറിന് നമ്മൾ ചെക്ക് ചെയ്തിട്ടില്ല, ഈക്വൽ ടു ഇല്ല. സോ ആറിന് തൊട്ട് താഴെയുള്ള എല്ലാ റേഡിയസിനും ഇത് ട്രൂ ആണ്, കൺവേർജ് ചെയ്യുന്നു. ദാറ്റ് മീൻസ് റേഡിയസ് ഓഫ് കൺവേർജൻസ് മിനിമം ക്യാപിറ്റൽ ആറെങ്കിലും ഉണ്ടായിരിക്കും. ദാറ്റ് ഈസ് ഇറ്റ് ഷുഡ് ബി ഗ്രേറ്റർ ദാൻ ഓർ ഈക്വൽ ടു ക്യാപിറ്റൽ ആർ എന്ന് കിട്ടും. Now we have to show that n equal to fn of a divided by n factorial. For this we use the proposition in the first module, that is if f of z equal to in the form of a power series sigma n equal to 0 to infinity n z minus a whole raised to n, then there exists a derivative series. Also in the C part we proved n equal to fn of a divided by n factorial. That is we have here f of z equal to sigma n equal to 0 to infinity a n z minus a whole raised to n, and the kth derivative fk of z equal to sigma n equal to k to infinity n into n minus 1 into etc n minus k plus 1 into a n into z minus a whole raised to n minus k. By substituting the values for k we get each value of a n. K equal to 0, then f0 of z equal to f of z itself. 0th derivative means function itself. So sigma n equal to 0 to infinity n z minus a whole raised to n. That's equal to a0 into z minus a whole raised to 0 plus a1 into z minus a whole raised to 1, etc. So f0 of a equal to the first term a0 itself. It is f0 of a equal to a0. Then by putting k equal to 1 we get f dash of z equal to, by the derivative series it is sigma n equal to 1 to infinity, k to infinity ആയിരുന്നു. So k equal to 1 ആയതുകൊണ്ട് 1 to infinity n into a n z minus a whole raised to n minus 1. First derivative n into a n z minus a whole raised to n minus 1. That is f dash of a equal to, by expanding we get 1 into a1 into z minus a whole raised to 0 plus 2 into a2 into z minus a whole raised to 1, etc. plus etc. So f dash of a equal to first term a1 itself, and by continuing this we get f double dash of a1 means it is a1 by a1 into 1 factorial, etc. So continuing like this we get f double dash of a equal to 2 factorial into a2. Therefore a2 equal to f double dash of a divided by 2 factorial, etc. In general we get n equal to fn of a divided by n factorial. So the power series of f of z exists and its radius of convergence is at least capital R. Also n is equal to fn of a divided by n factorial. That is the proof of the theorem. Thank you.